Hello guys, welcome to my IT class. We are going through a bridge course for data structure and algorithms. In the last video I discussed about pointers and their use. In this video I will be discussing again an important concept related to data structure, that is memory allocation. What is memory allocation? When you want to store data values in memory, you must allocate it. That is the rule of the language or program. You must create memory, you must allocate memory, then you can store it. That's the rule of C++. So that's why you need to declare variables here. So that by declaring we allocate memory. Now there are two schemes of allocation. One is a static allocation and dynamic allocation. So what is static allocation? Here the memory will be allocated to the variable at the time of compile. Say you are compiling, your program is getting compiled line by line. When it encounters a declaration statement, say like here int x. So this is a statement now, int x. So here for x the memory will be allocated depending on the system. Like if it is a Linux system or Windows, 4 bytes of memory for integer, again for price 4 bytes. So this memory allocation is done at compile time. That's why it is called static allocation. So another example where we use static allocation is array. When we create an array, we allocate memory statically. How you say it is statically? Because if you don't mention the size here, so this is the size. Here we must mention size of the array. If you don't mention the size, the statement, it will not accept the statement. It will not accept the array statement, creation statement. So this size has to be a constant. Has to be a constant. That is the rule for creating an array. If you give any variable name over here, then also variable name it will not accept, because variable will get value at runtime. So at compile time, the compiler is not knowing what is the value held by n, so it will not be able to allocate. Here in this example I have given empty square braces, so I have not mentioned size. What does it mean? It is still working. Why? Because when you initialize statically, you are initializing, you are at the time of declaration itself you are initializing an array. So when you do so, the number of items the compiler or the system takes into account and accordingly it allocates. That's how here giving size is optional. You can give or you can skip it. But when you only declare, later on you initialize, like the second case, roll number, int roll number. Here the size is must, and that has to be a constant value. Say in the float height size, we can't say whether it is a right statement or wrong statement. Why? Unless you know what is size. Unless you know what is size. If size is declared before this array statement, if size is declared like this, int size is equal to 100. If this way it is declared, then the statement, the compiler will not accept this statement, because size is variable now. By declaring this way, you are creating a variable size, and that size is coming as a variable here. Array will not accept the size as variable. It has to be a constant. So if it is a statement like this, then say if this is the statement like this, then it accepts constant int size, because size has become now constant, the array will accept. So it indicates that array uses a static allocation. What is the advantage of using static allocation? Simple to use and quick, and no headache of pointers over here. You need not handle the memory yourself, the system will take, because all that is allocated in stack memory. Perhaps you know the memory segments. Whenever we talk about memory, say RAM, it has 4 major segments, like code segment, extra segment, stack segment, and heap segment. So code segment is one where your code resides, program resides, and extra segment is one where global variables created through external keyword are available here in extra segment. At stack is one which is of our interest here, local variables. Whenever we create some variable in a block, I have discussed already this concept. So a block is what? Anything declared between, anything created between these two set of braces is a block. So anything created between these block is local. So such local variables are created or stored in the stack memory, and this heap is for dynamic allocation. We'll come to this in the dynamic allocation case. So all these variables will be allocated or will get memory in stack. Then who is handling this memory management with static allocation? It is the system. When they are created in a block, they'll be given memory from a stack. When the control exits the block in which they have been created, they will be destroyed automatically. So you don't need to create, you don't need to destroy. When you declare, they will be created. When the control exits the block in which it is created, they will be destroyed. So the memory management is automatic here. That is the main advantage or major advantage of static allocation. You don't have overhead of managing the memory. But the drawback is what? You may fall short of memory, or you may get excess memory. Say in this case, roll numbers 100 you are given. Say if you store only 10 students roll numbers, then 90 memory allocated for 90 roll numbers, that much space will be wasted. So memory is an important resource. We must care about the usage of memory. We cannot be so negligent about it. So that's why we should go for dynamic allocation. And even if you need, say you want to store 101 students roll numbers, the number of students is 101, their roll numbers if you want to store, then you will fall short by one student, one location, or one roll number you will not be able to store. That is what the shortage will be there, or wastage will be there, because you have already allocated. You cannot now again allocate at runtime. That is what the drawback. Say it is like I can give you the example, hosting party, static allocation and dynamic allocation. How actually I'll correlate it. Hosting a party, you are hosting say party. If the number of guests arriving to your party, coming to your party is a fixed, say 100 guests are coming, so you will order some, you will give order to the caterer that prepare food for 100 people, 100 persons. So this is fixed now. If by chance due to some other reason 125 persons arrive, you will fall short with the food, and due to some sort of problem, like due to rain, the crowd will not come. Say only 50% of your guests arrive, 50% of food will be wasted. So this is what the static allocation. Dynamic allocation is what? If you are hosting a party and it is not fixed how many persons would come in my party, maybe 100, maybe 150, maybe 25, so it depends. In such case, in such scenario, I will not fix 100. I will not tell the caterer that I want food for 100 persons. What I will say, I may need 150, I may need 50. So do one thing, you come here and prepare. If the 150 people come to my party, you can serve there itself at runtime. It is everything is clear to you. If 50 people come, if 50 persons arrive, so you will be knowing as per that you can prepare. So you are now doing preparation at runtime. So looking at the number of persons arriving, if more persons are arriving, you will be getting ready at runtime with all the items, and if less people are coming, you will be reducing the number of preparation of items. This is how you will manage it. That's what the runtime allocation and compile time allocation, static allocation and dynamic allocation. So and the example here now for memory, if you want to allocate memory at runtime, how it should be. For that, what the language provides? The language provides the new operator. C++ provides new operator. You may be familiar with dynamic allocation in C, like it uses malloc function. So here, since C is object oriented programming, we don't use functions. We make use of either objects or operators for it. So now new operator is used here. Say you can allocate memory for an integer like this. Say single integer, you can say new int. But when you make use of dynamic allocation, you must make use of pointers, because the new operator allocates a chunk or a block of memory and it returns the start address of that block, base address of that block. And this memory, dynamic memory, is available from this heap, this green block. This is for dynamic. Whatever memory you allocate at runtime, it is from heap, we call. So if you allocate, it is from heap, and when you delete it, it is removed from heap. You are allocating and you must deallocate it. So because this is what your allocation, say, look this at this statement, new int, new float, new char, you are allocating for, you are allocating. So when the job is over, when you get it done with the job, you must free the memory. If you don't free, what happens? It will create a hole. Memory leakage issue will be there. So again, for multiple values, you can allocate like this: str is equal to new char n. Now the difference between this float height size and str new char n, what is the difference? Here the size, because it is an array, here the size has to be constant, and here n need not be constant. N can be a variable. Say n is like a simple variable. Int n, you have initialized, say, n to some value. That time n can be a variable. In new, whenever we say new char, and whatever size we give, that size could be a variable. But in an array, it is not a variable, it has to be a constant. Let us see one example quickly. So here I will be demonstrating both examples, static allocation and dynamic allocation. Say I am finding average height of some persons, some number of persons are there, say n persons. Now here in static allocation I have to fix, like the caterer in the, when you were hosting a party, at that time you were fixing in static allocation 100 persons are coming. That way here 100 persons at the max I am considering. So then the memory will be allocated for 100 persons at compile time, and it will initialize this way: enter number of persons seen. Because I have given max 100, it could be 80, it could be 90, it could be 50, it could be 10, any value. So I will ask enter number of persons n. Say n heights you will enter here, then seen you will enter n heights. You will find summation of this heights, all heights you will find, add through this loop, and you will find the average. So this is the usage of array. When you use an array, height, seen height, you will use a subscript notation. We call this as a subscript notation. But this is important for us. This statement is important to us. This is array declaration and it is a static allocation, and the memory is from stack. So when we come out of this block, say we exit, say we are here now. We are here, we have exited the main. So they all variables created over here, so they are all local variables and they all have been created or given memory at compile time. They will be automatically destroyed by the system. We don't need to worry about it. Is that clear? Now let us come back to dynamic allocation. But the drawback of this program is what? The drawback is what? If we go for more number of persons, we fall short of memory. If we go for less number of persons, we will be having excess memory, wastage of memory. So wastage, shortage will be there. These two are the limitations. To overcome this issue, we go for dynamic allocation. So in dynamic allocation, what you do? You need to create a pointer. You need to use a pointer because the new operator, this new operator returns address, and that I will be collecting in a pointer variable, say height. Once I collect this base address, then I can use this pointer as an array. Say this is array notation itself I am using. Or you can use even the pointer notation. When you use pointer notation, the structure will be little complex because you have to add value at operator and plus parenthesis. You have to be little complex with pointer notation. It is left to you. You can use both notations. Though here array notation is used, but the memory allocation is dynamic itself. Here it is array notation and the memory allocation is a static because it is an array. So this is how we can make use of dynamic allocation. But this is very important statement here. If you forget this, here the hole will be created, because in dynamic memory allocation, the allocation job should be done by you and the deallocation job should also be done by you. Both should be done by you. If you forget this accidentally or unknowingly, then out there you will create a hole. How many times this program runs? That many times this much block in the heap, because this memory is coming from heap. So that much block will be there in the memory alive. The memory will not be automatically deallocated when the control exits this block. Even after exiting the block, the memory will be there if you don't give this statement. That's why it is always a good programming practice to take care whenever you manage memory that the deallocation is done properly or not. So I hope this is clear to you. Now I'll go for a few more examples. You can try them at home later. Say these are the examples. Similar way, the way I stored heights dynamically, you store dynamically balances of n accounts and display defaulters list. If the balance is less than 500, they are all defaulters. Store dynamically prices of n items and find the costliest max item. And similarly, store dynamically employee IDs and perform linear search, sequential search you have to perform. You try these examples and that will make your concept more clear. Now the final takeaways of this discussion are: give your attention here. For dynamic initialization of memory, use of pointers is a must. So you should become familiar with pointer. That already I have given one video for that. Through runtime allocation, optimum use of memory is possible. Why we should go for dynamic allocation? Why should have a overhead of pointers? The reason is that if you want to use proper memory use, optimum use of memory, then you should go for it, because there will be no wastage, there will be no shortage. Exact amount of as per the requirement, the memory will be used. And whenever you handle memory management, you from your side, you should be extra careful, because if you forget to delete, it will create a memory leakage sort of things. So with this, I'll conclude the session here. Hope you enjoyed. If you really enjoyed, you share with your friends. Thanks for watching. Take care. Bye.